The lights and other functions. We have now spoken about one of the two new control modules. What is the clue of the other one? Here we see nothing but two push buttons. This box basically switches connected elements on or off via 5 MOSFETs. I could have done that by simple latching switches as well. But with an Arduino, I just had more exciting possibilities. So I could add a small speaker for a confirmation tone, add flashing sequences like this dimming effect, hazard warning lights, pace car stroboscope effect, reducing the 24 volts from the e-pulse battery to anything below that by PWM, and so on. The headlights are very inexpensive, bright 12 volt LED elements with a small 3D printed bracket. Apart from the low power consumption, LEDs have a big advantage over light bulbs. They respond incredibly quickly, just what is needed to create a razor sharp strobe effect. The red 12 volt LED taillights are also a cool AliExpress accessory with another 3D printed support plate. These lights are universal elements that I can add to any ride in the future. They are not only cool, but in the dark half of the year they offer an undeniable plus in safety. Speaking of safety, also on the wheel loader I added the reflective stripes I presented on the locomotive project. At the wheel loader's top is an orange rotating beacon that runs with an internal battery. The integrated magnet was not strong enough to keep the beacon safely in place with the provided self-adhesive steel plate, so I designed this Infento compatible base that is attached with a 60mm M8 bolt to the Infento profiles. It supports the beacon on its full outer circumference, while the bolt heads acts as a magnetic counterpiece for the beacon. These beacons are also inexpensive Chinese gadgets, available in standard and mini size, and they do not only come in orange but also in red and blue. How cool is that for an ambulance or a police patrol? The smoking exhaust pipe. The red button on the third control box enables the exhaust smoke feature. Yes, you heard right, the electric wheel loader generates exhaust smoke. That's like a Tesla using a petrol engine. Brave new world, here is another feature I worked on for 2 weeks. The exhaust pointing upwards is of course only a dummy, which I built from a cheap grey 40mm switch pipe from the DIY store with 2 3D printed cones and an Infento compatible bracket. Of course, I will make any 3D models presented in this video available to you. Just drop me a line in the comments section and I will upload the model to Thingiverse, where you can also find many of my previous project accessories. For the smoke I used an aquarium pump to create some airflow through 2 e-cigarette vaporizers with fog juice from a fog machine inside. This trick also works great with glycerine instead of fog juice, then the smoke is even more dense. I admit the smoke is a bit too slow to look realistic. In future I should think about adding a small fan. Anyway, the kids really loved this feature, but unfortunately the vaporizer coils turned out being not suitable for continuous operation. After some 5 minutes the outer plastic was melting and at least one coil quit its work for good. The Liftarm's Kinematic. The Liftarm's Kinematic of a modern wheel loader is more than a parallelogram. The shovel needs to tilt by 180 degrees because the shovel needs to point upwards with the lift arm at the bottom to keep the gravel in, while it has to point downwards to empty the shovel with the lift arm at the uppermost position. This is something you won't achieve with a simple parallelogram. This is why we find nowadays the so-called Z-Link Kinematic. It is called Z-link because the 3-piece leverage for tilting the shovel is folded like the letter Z. Finding the right leverage layout is a super complex job. Firstly, you want the shovel to stay mostly upright when the lift arm goes upwards without needing to use the tilt actuator. Next, the Infento joints are restricted in terms of angle to some 210 degrees. As on any kinematic layout, the profiles in joints must not collide in any possible position of the two axes. Generally, lever systems must not work too close to their possible dead points because the forces are becoming very high, or it could cause the leverage to snap over its dead center to the other side. Last but not least, the linear actuators have a specific stroke and a total length. You want to exploit their full stroke, not more and not less. And you can't make them any longer or shorter. For the first time that I built with Infento, I used my CAD system for a digital mockup. I could define the axis of motion to give the virtual model the same degree of freedom as the real model. The basic lift arms layout was a downscaled parameter set I measured with a folding stick from an Atlas wheel loader that stood around in my neighborhood. Even having the CAD tool, finding the right parameters for the Infento wheel loader's lift arm took me almost 2 weeks. I didn't come around using some 3D printed profile spacers that are generally very useful. Furthermore, I also needed some spacers to bring the actuator's pivot points to their required locations. As a critical remark, I found that the movement of the lift arm was a bit on the slow side. If I did such a project again, I would buy 12V instead of 24V actuators and run them on 24V, so I would expect them to be twice as fast and twice as strong. If that was too much, I could limit the max power by the motor controllers by PWM. I don't think the linear actuators would overheat, as long as the lift arm is not being used for 10 minutes at full power without interruption.